Yes. All right, here we go. Section 4-6. We've got a triangle right here. Now, I drew the triangle so that this side would equal this side. Now, we've discussed this word before. Are we listening now? Let's listen now. I've started. Come on, pay attention. These two sides right here are equal to each other. We've already discussed what kind of triangle this is. Somebody tell me what this triangle is. When two sides are equal. It's isosceles. It's a right triangle? Come on, look at it. Come on, think first before you say. I don't mind if you just answer out, but think first before you say an answer, okay? Why would you say that's a right triangle? Just because does that look like a right angle? It might look like a right angle, but even if it looked like a right angle, is it a right triangle? You don't know it is until you put that little box right there to show it's a right triangle. Look, the only thing that I've shown on this triangle is this side is equal to this side. Two sides are equal. What do we know about a triangle when two sides are equal to each other? It's isosceles. Now look, let's spell this right. I am so tempted. I told my other class this. I'm so tempted to give you guys a spelling test because I go over how to spell this word over and over again, and you guys are butchering this word. You're killing this word, all right? And I've even showed you how to spell it. Isosceles. Isos. I-S-O-S. And then celes. What is C-E-L-E-S? That's all it is. It's isosceles. Even after I go over it, like Celine Dion, exactly. Okay, so isosceles triangle. Now watch. Let me see. What time do we get out of here? It's 1:40. I got 10 minutes. Okay, here we go. Watch. This won't take that long. I've got an isosceles triangle. By the way, if I have an isosceles triangle, this non-equal side, we give it a name. It's just a little quick vocab. It's called the base. These two sides right here are called the legs of the isosceles triangle. All right? This angle right here is called the base angle because it's the angle that's formed with the base. Follow me? Is there another base angle? Sure, because this one's also formed with the base. So this one right here is also called a base angle. Hope you're writing all this down. Okay. Well, that's what we're going to get to. That's a good observation. If these two legs are equal to each other, we have a theorem. And guess what? It's nothing real fancy. It's called the Isosceles Triangle Theorem. Okay, so this is what the Isosceles Triangle Theorem says. Are we listening? Yeah. A lot of whispering. Let's hush. Let's listen. Pay attention. Look up here. Focus. Up here. If I have an isosceles triangle, do you see these two base angles right here? Connor, what do you think they are? They are, and they absolutely are. Okay, they're equal to each other. So this angle will equal this angle right here. That's what the Isosceles Triangle Theorem says. If the two legs are equal to each other, then guess what? The two base angles are going to be equal to each other. Or in the book they say this, it's the angles that are opposite the equal legs. Do you see it? See how this angle is opposite this leg? And this angle right here is opposite this leg. What's this angle right here opposite? The base, that's right. But it's the two base angles are equal to each other. So watch. If I told you that this side was 5, and this side was 5, and this side was 40 degrees, could you tell me what this angle right here is? 40 degrees, that's right. Because of the Isosceles Triangle Theorem. Everybody understand that? Now, you could go the other way too. The Isosceles Triangle Theorem says if the legs are equal, then what? The base angles are equal. What do you think the converse of that would be? If the base angles are equal, then the legs are equal. You got it. So if I said that this was 40 and this was 40, and let's just pretend you didn't know what that side was right there, but you knew this side was 5. If this is 40, this is 40. What's true about these two legs? They're equal. So if that's 5, this has to be what? 5. Make sense? All right. That's pretty easy, isn't it? All right. That's the converse of the Isosceles Triangle Theorem. I won't write that down, but that's what we do. If the legs are equal, then the two base angles are equal. We're going to use that quite a bit. All right. It's very, very important theorem that we're going to use very often. Now watch. If this is 40 degrees right here, I'm going to put it right here in the angle. If this is 40, this is 40. What's this going to be up here? It's 100 because 40 and 40 is what? 80. Take 80 away from 180, right? So what's this going to be? It's going to be 100 degrees. So there's all kinds of things you could find with this, right? So if they tell you that these two sides are equal, these two angles are equal, and you can find that third angle as well. All right, let's do another one. That was isosceles triangle. Now we're going to do another type of triangle. Look at this thing right here. I tried to make it so this side would equal this side would equal this side. All right, so we call that an equilateral triangle. Very good. Okay, so equilateral. Equilateral is your favorite triangle? Okay. All right, so that's the equilateral triangle. Now watch this. An equilateral triangle is also isosceles, isn't it? Because it also has two sides right here that are equal. So let's label this ABC to make it a little easier for us. If AB is equal to AC, tell me something else that must be true. Angle B must equal what? Angle C. Everybody see that? Because look, if these two sides are equal to each other, the angles opposite those two sides have got to be equal as well. But look at this. Let's not just compare these two sides. Look at this. Look at AB and BC. See this side and this side right here? Okay, they're equal to each other. So guess what's true about their opposite angles? This one and this one. They must be what? They must be equal. So if this has one arc, what's this going to have up here? It's going to have one arc. So what's true about all three of my angles then? They're all equal to each other. Okay? So if it's equilateral, then it's equiangular. Okay? And I put an arrow going in both directions. Angular. Try to squeeze that in there. If it's equilateral, it's got to be equiangular. What do you think is true the other way? What's the converse of that? If it's equiangular, then it's equilateral. Exactly right. So if all three angles are equal, then all three sides are equal. So anytime you see an equilateral triangle, you know it will always, every single time, be equiangular. Right? It goes both ways. It goes this way and it goes this way. You get it? That's why I put the arrow like this in between them. Let's think of something else. We've got a couple minutes here. They're all equal to each other. Let's call that angle x. Let's call this angle x. And let's call this one x, right? X degrees. So that's the measurement of each of those. So that's right. So watch. What's true about all three angles? They add together to become what? With any triangle? 80. So watch. X plus what? X equals 180 degrees. What's x plus x plus x? 3x equals 180. What's x equal to? Divide both sides by 3, so x is 60 degrees. Every one of these angles right here is going to be 60 degrees. Every single time. Doesn't matter how big, doesn't matter how small. All right? Watch this. Here's that same triangle. That's an equilateral triangle right there. Watch this. What are all three of these angles going to be without even me measuring them? If it's equilateral, then every angle is going to be 60 degrees. Let me show you this. If I take this and put it right on top, bang, right there. Would you agree that that bottom left angle is 60? Right? If I take it up here and put it up there, that's 60, agreed? And then this is 60 right here. Okay? So if all three sides are equal, all three angles are going to be 60 degrees. I could make this any size that I want to. Right? I could have made this like more of a medium-sized triangle. Well, watch. Did I change the angle at all? Nope. Look, that's still 60 degrees. That's still 60 up top here, and it's still 60 down the bottom right. Okay? Make it bigger. Okay? Now watch. Still, look at that. Lines right up with it, doesn't it? All right? So it's still 60 degrees, isn't it? Agree with that? All right. That's pretty much it. All right? Let me give you a worksheet, and I'll let you do that for homework tonight.